What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
Tuning of VAZ engines is a direction that has existed for at least 30 years. There are a lot of recipes how to remove all 200 horses from a motor with a nominal power of 80 horsepower, not to mention the increase in output by 25 to 30%. But factory modification differs from tuning, at least garage, at least company, that engineers do not have the task to raise the power at any cost. They should provide the right balance of the massive indicators, many of which are in direct contradiction with each other. And the creation of a new engine VAZ-11182 is just an example of such work. Well, to understand this difficult issue, we took advantage of the fact that the test of the new Lada Largus, which will be equipped with the new engine, was attended by the head of the Bureau of Calculations and Validation of Power Units of AvtoVAZ Andriy Mikhailovich Avakumov. It would be a sin to miss such an opportunity, and we would like to share with you what we managed to find out during a very long conversation. Perhaps, the history of 1.6-litre 8-valve engines can be counted from 1985, when a 1.5-litre carbureted motor with the Index 21083 appeared in the VAZ engine range. Initially, it developed 51.5 kilowatts, that is, 70 horsepower at 5,600 RPM, on AI-93 gasoline, and was obtained from an earlier 1.3-litre VAZ-2108 motor by increasing the diameter of the cylinders. Naturally, this required a mass of radical changes to the design. This engine at the beginning of its life cycle stood under the hood of Lada Samara and cars of the 10th family. In 1988, a modification of the VAZ-11183 engine appeared, equipped with a modified connecting rod and piston group with a floating piston pin and the original camshaft. The power of VAZ-2110 engine was 52 kilowatts, 70.7 horsepower, but it was powered by AI-91 gasoline. By that time, the USSR was trying to unify gasoline brands with Europe. AI-91 and AI-95 appeared instead of AI-93. For a number of reasons, AI-91 did not take root, giving way to AI-92. The next important stage was the appearance of the VAZ-2111 engine in 1996, which for the first time in the history of AvtoVAZ was equipped with an injection system. This made it possible, while maintaining power at 70 horsepower, to meet -2 emission standards. Later there were several modifications of the VAZ-2111 engine with power from 51.5 kilowatts 70 horsepower to 56.4 kilowatts 76.7 horsepower corresponding to toxicity standards from R83 to -3 Starting from -2 standards, phased fuel injection was introduced. Both Lada Samara and 2110 were equipped with VAZ-2111 engines, along with carburetor engines 21083 and 2110. In 2004, a new engine with the Index 21114-21183 with a capacity of 1.6 litres was shown at the exhibition site in Togliatti. Interesting fact, one engine had two designations, as it was produced in two different shops. The motors were completely identical. The novelty was planned to equip VAZ Novelties, Kalina and Priora families. The main purpose of modernization was to increase torque at low speeds. This time, the designers increased the volume of cylinders by increasing the stroke of the pistons and abandoned the pair parallel fuel injection, stopping at the phased one. Replacing the underground neutralizer with a calculator, a neutralizer installed directly near the cylinder head, significantly increased the resistance of the exhaust system, but the increase in displacement allowed to achieve a power of 59.5 kilowatts 80.9 horsepower. The engine complies with -3 and -4 emission standards. Further evolution was associated with the introduction in 2011 of a lightweight connecting rod and piston group, an oval catalytic converter with reduced resistance, electronic throttle, semi-automatic tensioning timing belt, elastic belt drive auxiliary units. On engines with indexes 21116, 11186 and 11189, which developed power up to 64 kilowatts 87 horsepower and complied with -5 and 5+. Unfortunately, on this engine modification, the piston became plugged, that is, when the timing belt breaks, the valves bend, which significantly reduced the share of consumer sympathy. When modernizing the engine 21116-11186 for Lada Vesta, the motor received modified intake, exhaust, and suspension systems, and at the same time the index 11189. Nevertheless, not getting under the hood of the Vesta for marketing reasons, since 2015, the 11189 engine has been used in the Lagos. Since July 2018, its piston has been returned to pistonlessness with simultaneous optimization of the side profile of the piston, and replacement of the anti-friction coating of the skirt with a more wear-resistant one, which virtually eliminated piston scoring at cold start and driving in an unheated state. Well, the top of this 8-valve evolution was the VAZ-11182 engine presented in 2021. There is a legitimate question: why in general to hold on to the scheme with 2 valves per cylinder, if back in 1992, VAZ showed a prototype 10 with a 16-valve engine VAZ-2112, developing 94 horsepower, that is, 16 horsepower more than the 8-valve counterpart. About the history of the creation of this motor we have told in detail. And Lada Lagos is equipped with 106 horsepower 16-valve VAZ-21129. Planning the modernization of the 8-valve engine, the factory designers have set themselves a bar, not to make the maximum power above 67.5 kilowatts or 90 horsepower. In terms of physics, this equality is inexplicable, and it is entirely on the conscience of tax officials. The fact is that manufacturers who produce cars with engines with a power of more than this value pay an additional excise tax, increasing from year to year, which inevitably leads to an increase in the price of the car. Then maybe it would be easier to defortify the 16-valve engine? No, not easier. The 16-valve engine has a different head, 2 camshafts, more valves, which means that the cost of the unit itself is significantly higher. Well, since one of the objectives was to keep the price of the new car competitive, the 8-valve engine was considered the best option. 4 budget versions, which are more accessible to the mass consumer. At the same time, the 8-valve is even better adapted to operation in urban conditions, due to more favorable for subjective perception. Torque curve driving in the city becomes more comfortable. Yes, on the highway 16-valve, of course, will win. It has more power, and the maximum speed is higher. But for a light commercial automobile with a bias to universality, speed is not the main thing. Lagos is a rather heavy car, curb weight, from 1300 kg depending on the configuration. Therefore, torque at low revolutions is more important for such a car than peak power. And here, in pursuit of the torque at the lows, the VAZ designers have made very serious progress. Yes, the power indicators do not strike the imagination, but it is not required from the engine of the budget segment. It is important that there is an improvement. It is subjectively noticeable when testing cars, and this improvement has been achieved at a minimum cost of design changes. As you know, the main information about the engine is given by the diagram of VSH, external speed characteristic, showing the dependence of torque and power on the crankshaft speed. So, if at a speed of 1000 rpm, the former engine VAZ-11189 produced only 102.5 Nm, the new 11182, already 111.4 Nm. This motor comes close to the 140 Nm mark at 2500 rpm, while the predecessor had to be cranked up to 3800 rpm. In real life, this difference is felt at once, and at starting from a place, and at acceleration from relatively small speeds, and at movement with a full load. Well, now let's consider, at the expense of what it was possible to achieve the necessary indicators and what parts were affected by a serious modernization, because the changed parts directly affect the characteristics of the engine. And almost all of them are technologically and structurally very complex. Let's start with the cylinder head. It has undergone very serious changes. VAZ engineers completely changed the cooling jacket, changed the intake and exhaust channels, and optimized the combustion chamber. As you know, the chamber is formed by the blockhead and the piston itself. With the 189, the piston was flat, and the combustion chamber was formed mainly by the head. This configuration was chosen to use 133.32 mm connecting rods, which were unified with 16-valve motors. However, the flat piston did not allow the engine to realize its torque potential because of the need to reduce the ignition advance angle. This combustion chamber shape has less than optimal anti-detonation properties, and the only way to combat this phenomenon is to reduce the ignition advance angle. The new engine uses shorter, 128 mm long connecting rods from the 1.8-liter engine, and the volume of the combustion chamber is largely formed by an indentation in the bottom of the piston. This has improved the swirling of the fuel-air mixture flow and achieved significantly better mixing of air with fuel, and thus improved the anti-detonation properties of the combustion chamber, made it possible to use more optimal ignition advance angles and increased the compression ratio from 10.3 to 10.5. Increasing the compression ratio raises a legitimate question. Will it not raise the requirements to the octane rating of the fuel used? Because the higher the compression ratio, the higher the anti-detonation properties of the fuel must be. For all engines produced at VAZ today, it is recommended to use 95th gasoline, but when validation tests are carried out at the factory, the possibility of using 92nd gasoline is also checked, whether it can be refueled, whether it will not lead to any problems. Accordingly, in the operating manual of the car with engine 11182, there is a record that in the absence of 95th gasoline is allowed to use 92th. Nevertheless, all official indicators from the tables of technical characteristics are obtained when using gasoline with octane number 95, and to fully feel all the possibilities of the engine, it is necessary to fill it. In addition to the modification of combustion chambers, the VAZ-11182 engine for the first time used 3-piece oil rings instead of 2-piece ones. Time goes on, technologies change, suppliers offer new solutions. The factory tested these rings, and together with the new design of oil separator they showed good results. The oil loss compared to the previous engine fell by half. The oil loss, of course, depends on loads and revolutions. During the tests, for example, they compared the oil consumption of the 182 and 189 engines when running at 2000 rpm. On the old motor the oil loss amounted to 9 to 10 GRH, and on the new one, only 5 GRH. And the same picture can be seen in the entire RPM range. The carbon monoxide has been cut almost in half. The flame belt has also changed. It has become wider while keeping the piston mass unchanged. This has improved heat dissipation from the combustion chamber, while reducing the temperature of the piston rings. So, the engine has a new connecting rod and a new piston. At the same time, the piston remained non-piston. That is, when the timing belt breaks, there is no piston poking into the valve and bending the valves, because the piston has special notches for the valves. Such pistons now have both 16 and 8 valve motors, and they began to put them from 2018. Before that, timing belt breaks were a real problem, and now if the belt does break, the owner won't have to spend serious money to rebuild the engine. Again, many people may have a question. Why is the belt drive used and not the chain drive, which in theory can have a greater resource? The reason is simple. It is more expensive in production. Well, the declared belt life of VAZ engines is 180,000 kilometers. In general, the timing mechanism has been updated quite radically. The camshaft is now completely new. It was lightened. The width of the working surface of the cams was reduced from 15.3 to 11 mm, the width of the cam heads from 17.7 to 6 mm, and the profile was changed. The cam height was changed on the exhaust. The camshaft camber and phasing were changed, and in general, the weight of the camshaft compared to the previous version of the engine was reduced by about 500 g, from 2650 to 2069 g. The conditions of lifting and seating of the valve in the seat were improved, and this reduced the noise level, compared to the previous version. It was reduced by 2.4 dB. The valves have also become lighter, as the valve stem diameter has been reduced to 5 mm, making the valve itself lighter. The valve seats have also changed. If previously the seat thickness was 9 mm, now it has been reduced to 6 mm. The diameter of the valve sleeves has also changed. The oil caps have also changed. They were borrowed from the 16-valve engine of the Renault-Nissan Alliance. The design of the timing valve tappets has been completely changed. There used to be 2 springs and an adjusting washer. Now there is 1 spring and a tappet without an adjusting washer, so when adjusting the valves, the tappets themselves are changed. This solution is used both in Renault-Nissan Alliance engines and in many other competitors, such as Hyundai and Kia engines. As a result, the valves start to require adjustment only at a mileage of 90,000 kilometers. This is a good figure, but the main thing is that such a design allowed to refuse from zero maintenance and the first adjustment at 2,000 kilometers of mileage. True, now the adjustment procedure consists in replacing the tappets, which is more labor-intensive. The assembly technology has changed radically. Previously, The cylinder head was assembled separately from the engine at the factory, and the valves were adjusted on the cylinder head. The assembled head was placed on the engine, and the head mounting screws were tightened. In the process of tightening the screws, there was a slight deformation of the head, violating the adjustment of valve clearances. And as a result, at a mileage of 2,000 kilometers, valves had to be adjusted. Now the assembly is carried out on the engine. First the head is put on the engine, then assembled, then adjusted, and this ensures the accuracy of clearances between the tappets and cams. The engine top cover has been changed. Now it is made of aluminum, has 6 mounting points instead of 2, and is equipped with a new gasket for reliable sealing of the cylinder head cover. The oil separator has been redesigned to better separate oil from crankcase gases that flow back into the engine after oil separation. The quality of oil separation has increased 2 times. If on the previous engine it was about 2 GH, now it is less than 1 GH. Actually, the 8-valve engine did not have any problems with oil consumption, but new technologies allowed to make this situation even better. The designers have reduced the diameter of the throttle nozzle, thus making it possible to more accurately dose the air intake at low speeds. This allowed to reduce idling speed from 850 to 750 RPM, and this is very important for the consumer, as this indicator directly affects fuel consumption. At the same time, we can expect that the owners of cars with the new engine will forget about such a typical for 8-valve engines, such as the problem of floating revs. The cylinder block remained unchanged. The configuration of oil channels and cooling channels were changed only in the head, but the crankshaft design was modified more than significantly. The width of connecting rod journals was reduced from 27.2 to 19 mm, and their diameter was reduced from 47.8 to 43 mm. The number of counterweights has been reduced. On the old 8-valve engine there were 8, and now there are 4. This solution is also used on Renault engines. The scheme of oil supply to plain bearings has changed. Technologists have significantly optimized the production process. Previously, drilling of oil channels was carried out in 3 stages. Crankpin journals were drilled in one section, main journals were drilled, and then a diagonal channel through the root and connecting. Rod journals was drilled and plugs were placed. Now one diagonal channel is drilled from the surface of the root to the crankpin with exit on its surface, which allowed to refuse plugs and get a channel with one drilling. This did not affect the quality of lubrication, but not only reduced the cost of production of the part, but also improved the bearing capacity of the oil wedge in plain bearings. In addition, optimized cylinder head gasket, spark plugs, roller collector, injector ramp housing and much more. So what's the bottom line? As a result, the VAZ engine lineup has a rather modern in design, attractive and, what is important, relatively inexpensive engine. Today it is certified according to -5 Euro plus standards, but the environmental standards will inevitably become stricter, and the engine has the potential to be upgraded to -6 Euro, and in general, the potential for its modernization has not been exhausted yet. In any case, it will definitely be in demand for the next 5 to 6 years. In conclusion, the new 8-valve VAZ-11182 represents a significant advancement in automotive engineering, showcasing a thoughtful design that prioritizes both power and torque. By optimizing the combustion process and enhancing airflow, this engine achieves impressive performance metrics that elevate the driving experience. As we've explored, the careful balance of innovative technology and traditional craftsmanship ensures that the VAZ-11182 not only meets modern demands but also sets a new standard in its class. Thank you for watching, and stay tuned for more insights into the world of automotive innovation.